You almost have to deburr it. Should put shampoo in there. What you see printing now is, I believe, part of the check valve. I made it in two pieces, and inside there's going to be a check valve, and actually what's printing now is the check valve housing. One's going to insert into the other with the check valve inside. The way I designed the check valve, if you saw in the CAD drawing, it will not require a spring. It's just going to be floating around, and the minute that it has suction on it, it's just going to seat the valve, right? You don't need a spring in that case. This is the second portion of the check valve body. I just started printing it. It took close to an hour to print the other one. Should be the same for this one. After this one, I'll be printing the check valve itself. And I forgot, I gotta print two of these, one for the intake side of the pump and one for the exhaust side of the pump. I printed two of the same. Good thing I have to make two of these. This is just support material. It's already loose. See? It's too bad there's a lot of waste in support materials. Not that the material's that expensive, but see, these are two of the same. So now I gotta print the outer casing and then print the check valve that's going to go in these. I know it's kind of large. I was really struggling with which kind of check valve I should actually make. either just a little trap door that would shut open and close with a spring, or actually with a check valve and check ball with a spring. Or but the way I designed it this way, I don't need the spring, right? So this is the second piece of the body for the check valve. Once again, I have to print 2 of these. I had some problems, and I'll show you a picture after this video. What happened was, since the inside is hollow, right, it wanted to print bracing material for the intake portion of it, where I'm going to put the hose, and it wasn't connected to the exterior diameter, so it just started moving around after a certain height. The base wasn't strong enough to keep it stuck to the moving platform there. So I had to actually enclose. The bottom isn't hollow anymore, but it's only got 10/1000ths of material, and I'm going to cut it out with the utility knife. This way the interior support doesn't wiggle around and come unglued from the table, right? But it seems to be doing okay now. So the print is over. It didn't fall over. The support material held up. Now, all I have to do is see if I can't bust the base of this thing. There it goes. See? And this was the support material. But it was printing it just on the base. It wouldn't grab onto anything. So when it was printing, it would just wobble over. And so since I closed off the bottom, just 10/1000ths of an inch was enough to hold this in place. So I would have bridging material to print this upper stack here. That's where the hose is actually going to click onto, right? Okay, so I'm going to print another one. Well, it fits inside the other piece, right? But it's kind of got a lot of slop, or free play, or the fit is loose, whatever you want to call it. I know that the epoxy will take this fit to another level. It can actually seal up this joint and everything, but yeah, I'm not gonna redo the program. If I was doing a lot of these, I would try to get a better fit in the programming. That way I would get consistency or repeatability, right? So the little check unit's going to go in this one, and then epoxy this shut. It's just going to clack around in there, right? But when you actually suck and pull or push, it's going to do its thing without that spring, right? So I don't have to do any bracing for a spring inside of there. Well, I'm finally on one of the last components of the pump. This is the actual check valve. I'll show you a picture of it later, or I think I showed you a picture on the CAD drawing. As you can tell, it's shaped like a cone, and that cone's going to seat on the bottom of the valve. I hope that that cone is larger than a quarter, because I made the hose hole a quarter, and it's like two of these cones stacked on one on top of the other. The second cone's just to guide it so it doesn't get cross-eyed in the valve, right? And yeah, you'll see a picture of the valve later. So this is the finished valve. Just gonna scrape it off of there, and you see what I mean? Those little fingers over here are gonna retain it from actually clogging the other side. That's where the flow is gonna go. And this wiring thing on the bottom is where it's going to seal off in the hole. So I'm just going to clean it up and try it in the valve. Well, it's I got to resize this check valve. It's just a tiny bit too large. So I'm going to scale this a little smaller. Well, I finished the print, and this little check valve here, sorry if it's out of focus, okay, this time it actually fits in the diameter, right, loosely, and then there's the completed unit. You can hear it flicking around in there, right? So wherever it's pointing means that it's pointing on this side, so that's gonna let flow through, and this way it's gonna stop flow. It's gonna bottom out. So if you got two of them facing the same direction with the pump in the middle, you're going to get a flow out of one of the sides, and one's going to suck, one's going to, yep, one's going to actually evacuate the water from the bilge pump. Yeah, this is the second time I'm printing the retaining ring for the bilge, or the rubber part of it, which will be flexing. I need that. It's actually going to be a rubber glove, but I need something to hold it down to the casing or the body of the pump, and I needed a retaining ring for that, and I printed one here, right? It does fit on the pump, but the ring is interfering with the datum or the pivot of the lever. So I'm printing another one that has a cutout to provide room for this lever, so I can actually compress that rubber there so it'll hold it in place, and then I have my lever going up and down, which is going to retract and compress the bilge, so I can siphon water. That is the lever mechanism for the bilge pump. Pretty cool, huh? Hope it works. I didn't say that. Well, I got the finished product. So big I can't even get it in one frame. It's not pretty, but those check valves should work on either end. And the pump has a bellow. And it should move. It all depends on the stroke of that piston, right? On the plunger. If it could move a full volume, it would be moving for every stroke of that pi cubed. A volume of pi cubed. Right? So I'm gonna go over to the zinc and see if I can't get some water to flow through this thing. Okay, here we are at the high-tech testing facilities to see if this pump will actually pump water. I don't know if I got you in the frame there or not. Maybe that's better. I might be in the wrong end of that. Maybe it's in this end. And I gotta get some water in here first, I think. So I got the flow wrong, I think. Maybe this is my check valve. I loaded up with water. That drained pretty quickly. If I go that way, it's holding water, so that check valve is working. So the flow is from here to there. I'm going to load it up with water. It's siphoning, but it's not efficient. There's some leakage. The bellow isn't big enough, I think.